equations. Fortunately, there are three particular cases where you can, in some sense, reformulate the problem and get a tractable equation. One is in the situation where all the players have independent noises. You know, they have uncertainties, and from one player to the other, they are completely independent. In economics, that's rarely the case. In physics, that's very often the case. Then it's possible to reduce this infinite-dimensional equation to a forward-backward equation. So this looks like a forward-it equation coupled with a forward-backward-it equation. So this is completely unusual. This is not something that you will find anywhere. And it contains, as particular case, lots of equations. I don't want to lose you, so let me go fast. Another extreme, this I don't like it, but that's okay. Another example is in a discrete space. You know, X, the attributes were like age, position, wealth, continuous numbers. You may also decide that X takes only a finite number of values, in which case those equations become more classical equations, and they become equations which are non-conservative hyperbolic systems. Non-conservative hyperbolic systems, for which there exists some literature, but many more open questions than answers. Okay, what else? That might be even worse. This is another point of view. It's possible to recast all the monster equation in a problem which is also infinite dimensional, but instead of working on the space of measures, you should work on the space of random variables. I don't want to spend too much time on that, but this is absolutely crucial for many mathematical statements, which in fact you can show that the problem is well posed in the small thanks to this formulation. And the idea is more or less, and you know, you have a large number of points. Forget that this is in R3 to the n or RD to the n. Think of a function on the space of measures. But you can also think of it as a function on the space of random variables. And this makes life much simpler. So you have to create some differential calculus. Some friends call it the Pierre-Louis differential calculus, but that's just learn your differential calculus. Forget about those fancy differential calculus. That's already good enough.